go to find the maximum or the minimum value of the given linear programming problem. So we already have in our mind to solve these problems. But before, since this chapter has not been done in a school, we thought of doing this one first here, as the basic requirement lesson, and then only we can go to this problems which comes in the examination. Now let us quickly revise whatever we did. Like if we have to solve, if you have to draw the graph of, say, x is greater or equals to 0, then yesterday or day before yesterday, before yesterday actually, where was the solution region of x is greater or equals to 0? Where was the solution region when x was greater or equals to 0? Does anyone remember? Where was the solution of x greater or equals to 0? Is this the solution? Can you see on the graph the colored part? So basically, basically, which quadrants do we have values of x greater or equals to 0? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? In which quadrant? In which quadrants do we have the values of x greater or equals to 0? You can see here on the screen, the colored one. I think you can recall what color this was. We have done this one yesterday, day before yesterday also. Which color is this?
Pink.
Or Miss Dakal, which color is this?
Pink.
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 Okay. So is the pink colored region lying on first quadrant and fourth quadrant? Is the pink colored region lying in the first and fourth quadrant? So,
Yes, sir.
if you take any point on either on the first quadrant or the fourth quadrant, the value of x will be greater or equals to 0. And on the line x equals to 0, which is y-axis, the points will be x equals to 0. All right. So we can draw this one manually also in our notebook. Other one, if y is greater or equals to 0, if y is greater or equals to 0, then where will be the solution? Can you guess? If y is greater or equals to 0, in which quadrant will the solution region lie? Can you guess? Okay, first let's see. Let's talk about x only now. X less or equals to 0. Where will be the solution for the inequality x less or equals to 0? Can you guess? Ms. Dakal, can you guess the solution region for x less or equals to 0?
Second quadrant and third quadrant.
Second quadrant and third quadrant. Okay, let's see here. Yes, Dakal is correct. So in the second quadrant and in the third quadrant, the values of x will be less than 0. And on the boundary line, which is the y-axis here, where all values of x are 0, we'll have x equals 0. Otherwise, if you move to the left side from this line, the boundary line, which is x equals to 0, the values of x will be less or equals to 0. Similarly, if you talk about y greater or equals to 0, which region will have y greater or equals to 0? Can you
First and
guess?
second quadrant.
First and second quadrant. Okay, let's find out here. Today my network is not good. y y is y is greater or equals to y is greater or equals to 0. The solution will be the solution will be, as Dhakal said, you can see here, the solution is in the first and second quadrant, right, Mr. Dhakal? Did you say that?
Yes, sir.
Okay. Similarly, if we have to plot the solution region for y less or equals 0, which part will be the solution region for y less or equals 0?
Third and fourth quadrant.
Third and fourth quadrant. Third and fourth quadrant. Yes, you can see here that the third and the fourth quadrant will have the solution region for the linear equality with one variable, which is y less or equals to 0, will have the solution region in the third and fourth quadrant. All right. Now, 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 the basic solution, like, uh, for example, if you have to plot x, if you have to plot x, let's say less or equals to any number, say any number. Yeah, Mr. Gal, tell me one number.
4.
4. Okay. X less or equals to 4 भनेपछि in which region will this will the solution region lie? First, what will be the boundary line? What will be the boundary line? Is it x equals to 4? Be the boundary
Yes,
line.
sir.
X equals to 4 will be the boundary line. So x equals to 4 भने नि x equals to 4 भनेको is it the line parallel to x-axis or parallel to axis? X equals to 4, is it the line parallel to x-axis or parallel to y-axis?
Parallel to y-axis.
Parallel to y-axis, right? Parallel to y-axis and passing through the point, passing through the point, passing through the points, let's say 4 units away from y-axis, right? So you can see here, what did Dakal said? What did you say, Mr. Dakal? Did you say to the left side or to the right side? The solution region of x less or equals to 4.
I didn't say anything, sir.
Okay. So we have the boundary line, which is given by x equals to 4, which is the line parallel to y-axis, as Dakal said. And since we have to find the solution region for x less or equals to 4, we move to the left side. If we move to the left side of this boundary line, then all the points will have the values of x less or equals to 4. Now let's talk about x greater or equals to any number. Let's say, Mr. Kal, once again.
7.
7.
Yes, sir.
Oh, okay, 7. Let's say. So, what is the boundary line here? First of all, what is the boundary line? Is the boundary line x equals to 7, which is parallel to y-axis, right? And the solution region will be to the left or to the right of the boundary line. Will it be left or will it be right to the boundary line?
Right to the boundary.
Right to the boundary line. Boundary line is the line which is given by x equals to 7, which is the line parallel to y-axis, and the solution region for the inequality x greater or equals to 7 will be the region to the right of the boundary line, right? Now let's talk about here about y less or equals to any number, less or equals to which number? Oh, Mr. Kal, tell which number?
3, sir.
3. Okay. So what is the boundary line first of all? What is the boundary line? Is the boundary line y equals to 3?
Yes, sir.
No. Yes. The boundary line is y equals to 3 and the solution region will be below the boundary line, right? Now, if this was not less or equals to, if it was less than 3, then see here, what difference do you see? when we have to plot the linear inequality with one variable y less than 4, then do we have the straight line over here, the boundary line? Do you have the straight line? No, we don't have the straight line. We have the dotted line, which we have talked yesterday also while drawing the solution region for linear inequality manually, right? So the applications also show that the solution region for y less than 3 will not have the boundary line, or which will not contain the points of the line y equals to 3. It will contain the points below the line y equals to 3. That's why the straight line is not straight over here, it is dotted line. All right, so you have come to understand that you many things about this plotting the lines, linear equality, lines in the form of linear inequality, and find its solution region. Now let's talk about how to draw manually in the examination, because we cannot use the application in the examination in Nepal yet. We can use the manual usual calculator, not the graphical calculator in the examination in SCE. So if we have to draw, suppose for example, let's take a question over here. Prashna, Dokal, Ayush. Is Ayush there in the class? Okay, let's forget. Maybe he will come back. Now you have to maximize. We have a question here where you have to maximize. We have to maximize the objective function, which is given by f equals to 4x plus 3y, 4x plus 3y, subject to the constraints given by the linear inequality with two variables, x plus y is less or equals to 6, twice x minus y is greater or equals to 3, and x is greater or equals to 0, y is greater or equals to 0. Now, first of all, you have to plot these two linear inequalities, this one and this one. So to do so, what we have to do is we take here the linear inequality. Let's say you have here the linear inequality x plus y less or equals to 6. So yesterday we talked about the process, the steps, how to draw the graph, how to find the solution region for the linear inequality. So can anyone recall what we did, what we talked yesterday? About the steps of finding the solution region for the linear inequality.
Changing it into equation form.
Changing it into equation, right? Thank you very much. Now let's say these are linear inequalities given by the name, first equation, second equation, and third equation. Now, so from one, as our friend said, we have to convert this linear inequality into equation in order to find the boundary line, right? In order to find the boundary line, we convert this linear inequality into equation. That's the first step. Now, from the first, after the first step, from the equation, not from the inequation, from the equation, what are we supposed to do here? What is the next step? Anyone remembers? What is the next step?
Find 2 points.
Find 2 points, right? At least 2 points, not only 2 points, at least 2 points, right? You can find 3, you can find 4, but it's tedious. So even if you find 2 points, that's perfectly fine if they are correct. In order to verify whether the points are correct or wrong, you can find more than 2 points, but 2 points are sufficient, necessary and sufficient. Now take any value of x in order to find the value of y. Yeah, Mr. Kal. Take any value of x.
2x2 y4.
X2, if x is 2, y is 4. Okay, another point.
x3 y also 3.
X3, y will be 3. So we have to plot these points and join them, right? Now it's not good to just simply draw the picture over here on my screen. Can you try plotting these 2 points on your, if you have graph copy, you can draw on a graph notebook. If you don't have graph notebook, then you can simply draw on the usual notebook. Will you try over there? Try to plot the 2 points, 2 comma 4 and 3 comma 3. Let's try plotting the points 2 comma 4 and 3 comma 3. X plus y equals to 6. How is the line that side, on that side? Did you get a straight line? The boundary line joining the 2 points 2 comma 4 and 3 comma 3.
Yes, sir.
How is the line? Okay, let me check here, and you can find out whether you did it correctly or something went wrong. So you got the line x plus y equals to 6. Okay, let's try. Let's try finding the boundary line for the second equation as well, and we can check later. From 2, let's find the points. The boundary line will be twice x minus y equals to 3. And from this equation, let's try to find the points, at least 2 points, so that we can draw a straight line x, y. Can we find the points? Can we find the points passing through this, passing, uh, having it on this line, twice x minus y equals to 3? So choose any point for x. Let's say if I say x is 0, if I say x is 0, what is the value of y? If I choose x equals to 0, what is the value of y?
-3.
Negative 3, right? Thank you. Arko, take any other value of x.
1.
1, all right. If we take x as 1, then
Minus-
what is the value of y?
-1.
Negative 1. Okay, let's plot these 2 points on the graph paper. If you have graph paper, you can use graph paper, or if you don't have graph paper, you can use your normal notebook. Yeah, do there x plus y plus y x plus y equals to 6. Okay, Did you get the line like this? Boys and girls, x plus y equals to 6.
Yes,
Did you
sir.
get the line like this? Okay. What was our second equation? Twice x,
2x
right?
minus y.
Twice x minus y equals to 3.
Yes, sir.
3, yes, 3. Okay. Now we got here. Did you get the lines like this?
Yes, sir.
Yes. Now, where are the now? Which one is the common part here? Okay, we forgot one thing here. We have to figure out the solution region for both of them, right? So, taking the testing point 0, 0 here, taking the testing point 0, 0 here. If we test on, okay, if we test on the first one, take testing point 0, 0, and put it over here. Will it be true or false? See there, check there. We want to see whether it is x plus y is less than 6 or not by putting the testing point. 0 is less than 6. Is this true? 0 is less
Yes.
than 0 is less than 6 is true, right? Now, 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 if this is true for the red line, where will be the solution region for the red line? Will it be below the line or above the line?
Above the line.
Oh, wait. Where is 0, 0?
Sorry, sir.
Where
Below
is
the
0,
line.
0? 0, 0 is here, right? 0, 0 is here. So this is the testing point is satisfying the inequality x plus y less than 6. So this means the solution region for the inequality x plus y less or equals to 6 will be below the red line. And let's check for this one. Twice x minus y equals to 3. Twice x minus 3 equals to 3 by taking the same testing point. Test with the testing point 0, 0 to see whether twice x minus 3 minus y is greater than 3 or not. And we don't have to check for equals to, because equals to is true in the in case of taking the points from the boundary line. So we have already drawn the boundary line, so we don't need to check on that boundary line. Now if we put here the value of x as 0 and y as 0, now 0 is greater than 3. 0 is greater than 3.
No, sir.
Is
It is
this
false.
correct? False.
Yes, sir.
Now let's see over here. For this, which color is this?
Blue.
Blue. Okay. For the blue line, blue boundary line, which part is the solution region? The left side or right side?
Right side.
Right side. Now tell me, anyone from that side, which one is the common solution region for this two? Which one is the common solution region? Any idea? Which one is the common solution region? Girls or boys?
Don't know, sir.
Okay, first of all, did you understand that the solution region of red line and solution region of blue lines were which part were the solution region for those two? Did you understand that first?
Yes, sir.
Okay, let's see here. Okay, one second, let me ask you here. For a red line, which one was the solution? Was it below the line, red line, or above the line?
Below the line.
Below the line. All right, keep that in mind. And for blue one, where was the solution region? Left side or right side?
Right
Right
side.
side.
Right side. Yes. All right. So red line below, blue line, right side. All right. Now let's see here. Now let's see here. Oh, the picture is not good. Okay, yes. Wait. Let me crop this one first. Wait a minute. Wait a minute. Okay. Now can you see the picture over here?
Yes,
Can you
sir.
see? Okay. Now, now let's bring it over here. It'll be easier then. Okay. Where was the solution region for the red line? Was it below the straight line, below the boundary line?
Yes, sir.
Yes. So we saw it like this. Below the red line was the solution region for the red one, which is the red line is actually x plus y equals to c equals to 6. The boundary line for the inequality x plus y less or equals 6, right? And this blue one was the boundary line represented by twice x minus y equals to 3. And the solution region for this one was, where was the solution region for this one? Blue one. Left
Right
or right?
side.
Right side. Right side means all the region. All the region left to this one is the solution now. Okay. Now, which one is the common up to now?
Below part between red and blue line.
Okay. And below part between red and blue means can we say this region? Can we
Yes,
say
sir.
this region? Can
Yes,
we
sir.
say this region is the common part, common solution region?
Yes, sir.
Okay. Now we should not forget the other component as well, other constraints as well. The other constraints where x should be greater or equals to 0. So here in this region, are the values of x greater than 0? Are the values of x greater than 0? Here,
Yes.
everywhere? Yes.
Yes, sir.
But do you have there the values of y greater than 0? Here on x-axis, the values of y will be equal to 0, and we want to have the values of y greater than 0 as well. So here, here are the values of y greater than 0?
No, sir.
No. So to have the common part of this one, and this one, so which part has to be eliminated here?
Sir, that fourth quadrant part.
Fourth quadrant part. Yes, that's great. That's perfectly fine. So now the solution region will be this one, right? This one is the solution region common in all four, satisfying all four conditions. X greater or equals to 0. Here the values of x are greater than 0, and here also y are greater or equals to 0. On x-axis, the values of y are 0, and above x-axis, the values of y are obviously greater than 0. Now, it's finally we have to find. We get here a closed figure. Can you see a closed figure over here? Can you see a closed figure?
Yes.
Closed figure. Now, find out the coordinates of this of the points. The three. Okay, what type of figure is this? What type of figure is this?
A
Triangle.
triangle.
A triangle. Now, can you find the vertices of the triangle? Can you find the vertices of the triangle? Let's say this one is A, this one is A, this one is B, this one is C. Can you guess the vertices of A, B, C, or the coordinates of A, B, C? I mean the coordinates of A, B, C. What are the coordinates of A? Understood? What are the coordinates of A? What are the coordinates of A?
3,3.
Are you sure 3, 3? Okay,
Yes.
3, 3. What are the coordinates of B? What are the coordinates of B?
6,1.
Coordinates of B.
5, 0.5.
Pardon. Kati?
1.5, 0.5.
1.5, 0.
0.5.
1.5, 0. Is it?
Yes, sir, yes.
Okay. What are the coordinates of C then?
6, 0.
6, 0. Now, these points will help us to figure out the maximum value of what was the objective function given to us. Look at here. What was the objective function? It was f equals to 4x plus 3y,
Plus 3.
right? Now, with the help of these three vertices, which are the vertices of the solution region in the form of a triangle, we will see which vertex gives the maximum value of um, z. All right. So we have to make the table in the examination as well, writing vertices A with the coordinates 3, 3, B with the coordinates 1.5, 0, C with the coordinates 6, 0. All right. And the value of f, the objective function, which is given in the form of this objective function 4x plus 3y, 4x plus 3y, 4x plus 3y, 4x plus 3y. What is the value of f when x is 3 and y is 3? Can you calculate and tell me?
21.
21. Thank you. What is the value of f when x is 1.5 and y is 0?
6.
6. And with x is 6 and y is 0. What is the value of f?
24.
24.
Okay. Now you can figure out yourself which vertex gives the maximum value of f.
C.
C. Okay. So this is the maximum value of C. Therefore, the maximum value of f is 24. 24 at which point does this happen? At which point? At A or B or C?
C.
At C. At C,
6,
which is 6, 0. So are you able to do now? Can you do one question yourself now?
Yes,
Yes.
sir.
Now, see, let's quickly summarize what we did here. So in the examination, you will be given either to, and by the way, did you get the question paper published by CDC for optional math for this SE?
No,
Did you get?
sir.
Did you get? No. Okay. So I'll send you that that you can find yourself also. I think all of you have access to the internet nowadays, so you can figure out. You can go to this website for um, CDC, and you can find the question paper of option math over there. It's published now. So now we have been given here objective function with constraints in the form of linear inequalities with two variables, x plus y less or equals to 6, twice x minus y greater or equals to 3, x greater or equals to 0, y greater or equals to 0. So it's not a big deal to find the solution for x greater or equals to 0 and y greater or equals to 0, because x greater or equals to 0 and y greater or equals to 0 will happen only in the first quadrant, right? So the solution region always lie in the first quadrant if these two linear inequalities are given. Are you convinced with this one? X greater or equals to 0, y greater or equals to 0 go. It happens only in the first quadrant. Do you believe? Do you agree at this point? X greater or equals to 0 and y greater or equals to 0 go. Is it in the first quadrant?
Yes, sir.
Yes. So we have to find the intersection of other two linear inequalities, inequalities in the first quadrant. All right. Now, so we have talked about the steps how to find the solution for the linear inequality either in one variable or two variables. So here we have been given linear inequalities with two variables. Say we have given name it as first equation, first inequality and second inequality, and the next step is to convert this inequality into an equation, which is the boundary line, which we call the boundary line. From this boundary line, we have to find at least 2 points, plot them, and with the help of the testing point, usually the testing point is considered as origin, which is 0, 0. We find the solution region for this first equation, first inequation, and then similarly in the similar manner, we find the 2 points from the boundary line obtained from inequality second or inequation second, and with the help of the testing point, which is normally taken as 0, 0, we find the solution region for this both, and the common region for this two linear inequality is was was this portion actually. It was all this, but we have to consider these two as well, these two constants as well, where x should be greater or equal to 0. Here x is greater or equal to 0, but y will not be greater or equal to 0, so we cannot include this one. So we have not taken the region below the x-axis. So the solution region always lie in the first quadrant if these two constraints are given in the examination, this one and this one, where x is greater or equal to 0 and y is also greater or equal to 0. And after finding the solution region, which can be in the form of a triangle or in the form of polygon, you should be able to find the vertices of the polygon either in the form of a triangle or square, parallelogram, quadrilateral, whatever the shape of the common common region is. And with the help of the vertices, with the help of the coordinates of the vertices, you can find the value of the objective function, say the value of f over here, which happens to be 21, 6, and 24 at various points. At A it is 21, at B it is 6, and at C it is 24. So we are supposed to find the maximum value. That's why 24 is the highest in these three numbers. So we say that maximum value of the objective function f is 24, which happens at the point C with the coordinates 6, 0. Or in the same question, if the question was asking to find the minimum value, then we should have said that the minimum value of the objective function f is 6 at the point B with the coordinates 1.5, 0. All right. Can you draw on your graph notebook now, like this? Can you draw?
Yes, sir.
Yes,
Boys
sir.
and girls, if there is any boy, if
Yes, sir.
girl, if there is a
Yes.
girl, obviously girl. Is it fine? Okay, all right then. Now we have few minutes left. So let me quickly make you one um, small exercise. Let's take one example over here and let's try to find the solution for that one. Say if we have x plus y less or equals to 6, x minus y less or equals to 4, and x greater or equals to 0, y also greater or equals to 0. Yeah. Can we find manually? Let's do it roughly. Now from this inequation, what is the boundary line? What is the boundary? Yes, boundary line. X plus y equals to 6, right? So what are the points which can be taken from this boundary line? Quickly, what are the points? Is it 3, 3? Is it 3, 3?
Yes, sir.
3, 3.
2, 4.
2, 4. All right. 2, 4. Now you get a line like this, right? You will get a line. We'll get a line like this. Now testing point, if you take 0, 0, if you take 0, 0 and then put it over here, 0 plus 0 is 0. Is 0 less than 6? Is 0 less than 6? Is 0 less than 6? True?
Yes, sir.
Yes. So the solution region will be below this line. One condition.
Sure.
And the another boundary line will be x minus y equals to 4. And just take points, simple points.
4,
If you say x is 4, if you say x
no,
is
sir,
4,
6, 2.
6, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6, 6 and 2,
6,
right?
2.
6, 2. 6, 2. And which one more?
6.
One more.
8, 6. Or 5, 1.
5, 1.
So 5,
1,
1.
2, 3, 4, 5. 5, 1, right? 5, 1. So the line will go like this. Line will go like this and like this. Now, if you take the testing point 0, 0 and put it over here, 0 minus 0 is 0. 0 is less than 4. Is 0 less than 4? Correct?
Yes, sir.
Yes.
Yes.
So where is the solution region for this line? Red one.
Left.
Left? Left. So this one is the solution region. So which one? And we have to take the solution region only in the first quadrant because we have been given these two constraints. So which one do you think is the solution region? Is this the solution region? Is this the solution region? Common part. Now, is it
Yes,
in
sir.
the form of a triangle or quadrilateral? Look at here. Is it in the form of a triangle? It's quadrilateral, right? So that means how many vertices do we have to find?
4.
4.
Oh,
Okay. So can you guess the vertices? Can you guess the vertices? What are the coordinates of this origin?
0, 0.
0, 0. What are the coordinates of this point? What will be the coordinates of this point? So you can find this is not drawn on scale, so it will be difficult to figure out the exact location of these points. If you do this one on your notebook, graph notebook, then you can
Yes, sir.
easily find the coordinates of these points. So find this point, and find this point, and put it in the given objective function. which is given over here. Z equals to 10x plus 12y. So putting the values of x and y, you can figure out the points, figure out the point with the coordinates which gives the maximum value or minimum value as well. All right. This much for today. I don't have anything more. So Miss Lakal, good night. Ayush,
Good night,
good
sir.
night everyone. Good night
Good
everyone.
night, sir.
Right, sir.
Good night. Good night everyone. Good night. See you tomorrow.